Now, in this video, I'm just gonna proceed with u substitution. That's because substitution can be tricky sometimes. Let's look at this example. Now, in this example, you have u multiplied by the square root of u plus 1 du. So we need to evaluate the integral with respect to u. But notice now that you have a composition of this. Then the only thing that makes it hard to integrate is u plus 1. So let's substitute that in. Let v, or any other variable, you can use any other variable. Now let v equals u plus 1. Then dv is equals to du. But now we have a problem. Now we have a problem with this u out there. Remember, we're changing our integral to with respect to v. That means that we must solve for u. Since we have the u outside, I'm talking about this, we have this outside, then we must account for that. If v equals u plus 1, that means that u is equals to v minus 1. If you solve for u here, you'll get that u is equals to v minus 1. Then let's just plug that in. Let's just plug that in. Therefore, this integral can be expressed as where u, it's v minus 1. And now we have the square root where u plus 1 is equals to v. And now du is the same as dv. Then we can write dv. Then now we have this with respect to v. Now you can just multiply this. Then you have the integral of v times the square root of v. This is v to the 1, and this is the same as v to the half. And then you can have 1 plus half, which is 3 over 2, minus v. When you multiply negative 1 by v to the half, you'll just get negative v to the half. And this is dv. And when you have that, you can split the integral, or you can just integrate. So let me just split the integral. So you have v to the power 3 over 2 dv minus the integral of v to the half dv. Then you can apply the rule where I showed you what do you do when you have the variable that you integrate with respect to raised to any number but negative 1. Then you can integrate that. Now when you add 1 here, you're going to have 5 over 2. You're going to have 5 over 2. Now the reciprocal of that will be 2 over 5. So you'll have 2 over 5 v to the power 5 over 2. Now when you add 1 here, you're going to have 3 over 2. And the reciprocal of that is 2 over 3. So you'll have 2 over 3 v to the power 3 over 2. Then you can add a constant as well. But now we have a problem. Initially, this integral was we were integrating u. So that means we must plug u back. Now where there is v, we're going to place u plus 1 when there is v. So this will just be the same as 2 over 5 multiplied by v. I mean u, sorry about that. So it's gonna be u plus 1 to the power 5 over 2 minus 2 over 3 into u plus 1 to the power 3 over 2 plus c. Then you can further simplify this. I'm just gonna stop here. But then basically you can see how substitution works. Let me just do one last example on this. Now, suppose here, this case now, where we have the square root of x divided by x squared plus x multiplied by e to the power arctan root x. Now, in this case, you can realize that in the denominator, you can factor by x. So this will be the same as the integral of root x divided by x if you just factor by x plus 1 multiplied by e to the power arctan the square root of x dx. Now x is the same as root x multiplied by root x. Root x multiplied by root x is the same as root x, because the square root will just cancel. And then transforming that, you get something like this. So the root x and the root x can cancel. So then you'll have this simplifying to 1 over root x into x plus 1. And then you can just multiply that by e to the power arctan root x. So that's what you're gonna have. Now, notice that I'm gonna make my substitution now because I see something familiar here. I see that the derivative of arctan root x is the same as this. So, but then I can make my substitution. Let u equals arctan root x, arctan the square root of x. Then du in this case is gonna be the derivative of root x. The derivative of root x is 1 over 2 root x. And then you divide by 1 plus the square root of x squared. So that's basically deriving arctan. So it's basically like this. And then if you further simplify this, you get that dx is the same as 2 root x multiplied by 1 plus x. 1 plus x and du. If you solve for dx in this case, you're going to get something like this. Now, making that substitution in, you're going to have the integral of 1 over the square root of x into x plus 1 multiplied by e to the power u, and then multiply that by 2 root x multiplied by 1 plus x du. Now, we are integrating with respect to u. Now, notice that 1 plus x is the same as x plus 1. Notice that the root x and the root x cancel, and then you'll be left with the integral of 2e to the u with respect to u. So that's what you're going to have in this case. Now apply those rules I showed you about integration. Then if you apply those rules, you're going to have the 2 outside, and you have e to the u du. Now this will be the same as 2e to the u plus a constant. But now what's u? U is the same as arctan root x. So that's the integral of that using substitution. That's how you can evaluate that integral using substitution. So basically it's not that hard. You just have to know where you have to make that substitution. But now there are